Okay, today I'm going to show you how to build a 5-axis table head machines. Um, like what you have here, DMU60 on the block. The Y is on X, X is on the base. So if you look at the property, the X, this is the limit, and the home position is this, and the Y, and the B is at the head. Okay, B at the head, and the B at the head, and Z, the Z is on the base, and the C is on the Z. Okay, these machines. Let me skip the. That's C, the X, this Y, this is Z. Okay. This is the machine file. To start this tutorial, make sure you have this file, and you need to make sure this machine file, right? This machine file, you need to copy this file into this directory. Okay, this folder. So for me, I already done that. You see here. Okay, I've already done it. So make sure you just copy into this folder for the machines. And for the post, yep. So let me unzip. Let's make a copy of this file. I'm going to change the name of the machines. Maybe I'll change to this. Okay. So make sure you rename all the files. So you must rename all the files of the DIY post, the template post. Okay, so after you have renamed, and make sure you copy to the post directory. This is the post directory. Okay, just I'll move it to here and here. Okay, and then to edit the post, what you need to do is to edit these two files, the MCFG and the PGF. So I will open with a Notepad++. Okay. If you have go through the first the hash machine video that is shown here, this video, the second video, third and the fourth, if you have go through this video, then you should know where to get the Notepad++. Okay. And okay, so this is we'll start with the CFG. Okay, so alternate 0 to collapse everything. Just in case you cannot see some colors like that, you can make sure your language is gpp2 PGF. Okay. And okay, let's open up the startup, and we'll put the name here because this, let's change the name. No, the name of the, I will put this name. Let's copy and here. That's the name of the machines. Yeah, machine kinematic. Yeah. So this is a table head. So you have to choose number 3. Find X head table. So find head table or table head the same. So this will be the 3. Okay. You set 3 here. Save move. Yes. This one I will use number 2, so that I can move up Z and then go XY for the save move. Okay, and for this, yes, this parameter will affect the table head and head. Okay. So which one to set? 1 and 2. Okay. If this machine is heidenhain, then you can set 2. Okay, and you can set 2. If this machine is not heidenhain, then you have to set this one to be 1. What's the meaning? The meaning is for heidenhain machines, to move a TCP move, it allows you to move XY then Z. Okay, but for other controller you cannot do that. For TCP move, you have to always move XYZ. Right? So in this case, I'm going to put 2 here. And this one no need 0. Yeah, BC, no need to move 0 before TCP. TCP in heidenhain is M128. Yeah. Okay, now let's close that up. Let's look at the machine kinematics. Yes, 2 axis will be on the Z, the vector. This one no change. And for these machines, the B axis the vector is actually Y plus, and C is -1. So with this, I can always this one I put 0, right? So I can always define the vector by just this value here. Okay. So in this case, yeah, I'll set this one by 0, and this will be the Y plus. Y. Let's look at the B. Right, the tilting axis. So the axis rotation, it is Y plus. And this one is not valid because I've already set this one to 0. Okay, this will not valid. It will only valid if you set this one to 1. Okay, it means you want to define the rotary axis by vector instead of the text like this. Okay, the collector is B, uppercase. Make sure you put the correct one. The tilting axis limit is 30 to -120. So 30 to minus, this is 30, maximum is 30. By the way, the slash is actually command. Okay, anything behind the slash will ignore by default. So for this machine, I decided to set zeros and minus 120, so that the machine always will work on the negative side. Okay. Yes, this parameter set a 0 because this is a continuous axis. Yeah. Prefer angle, so choose 3. We prefer to work on the negative side, the B negative side. Yeah. How about the pivot point? Let's check. The pivot point for this is center rotation. Yeah. Let's make it 0. As you can see, here is the center locations, right? So we have a distance of x 100 and 260. What is this? This is the distance from spinner face. So this is 260, right? And the distance between this and the center, right? So this is 100. That's the meaning. So we need to set x 100, y is 0, and z 260. So x is 100. This one is 260. Okay, so that's for the B axis here. About the C axis, yes, the C axis, this one, the Z is Z minus. So I'm setting Z minus. Okay, so this one you can ignore because we set this one to 0, right? We are using the text to define the direction. And about the non-tilt rotary collector, that is the C, capital, okay, uppercase, must be uppercase. The rest is quite default. Minimum angle, maximum angle, shorter path. Yes, this machine is shorter path. And another meanings, on the heidenhain you need to put one M126. Make sure you put one M126 before running the program, right? And the machine will behave in the shorter path. Okay, this one you can ignore. Just ignore. Is this one? Yes, it's a continuous axis. Prefer angle. There's none. I'm going to set none. We don't prefer any angle for this non-tilt rotary axis. Okay, now let's close the kinematic and let's look at the machine limits. Okay, so first we need to set this X. Let's look at the X. So the X axis, the minimum is -715,130. minus 715 130 but why the y will be minus 280 minus 280 but the Z for this machine is 653 and 28. Six, 5, 3 and 28. Okay, so the safe position, this value I will take the X minimum. Yes, move. That means the home position of the machine is this one is X minimum, Y maximum, Z maximum. So I will not change. X minimum, Y, Z. Okay. And then the last parameter that you need to look at is this one, the table top center, this point here, right? This point. You need to get the machine coordinate for that point. That means for heidenhain there is M91 position, the M91 position for this tabletop center. For me, I'll set to minus 653 and the Y minus 280 and the Z, the X 715. Okay, so this value is very important. Make sure you get it from the machine. Okay, make sure you get it from machine. This one must be accurate. Yeah, that's it for the MCFG. Let's make sure you save the file. Okay, we already done the MCFG. Now let's look at the PGF. The default PGF, let me see what is the controller. This is house controller, right? So, and for these machines is running on the heidenhain controller. Okay, so let's go back here and let's look at the heidenhain. Yes, the heidenhain template. I will open this template with the Notepad++. So I just Control A and Control C to copy everything, and come here, Control A, delete, and then Control V to paste the heidenhain. Right. So after you paste, let me check anything else that we need to change. No. Yeah, I think I need to add one code here at the beginning of the program. This is the beginning of program, so maybe here I'm going to add M126, right? So that the machine is so that we can set shortest path on, okay, for heidenhain. I think M126 is not inside this standard, right? Let's make a search. Yes, so I need to add. That's it. My MCFG file is done, finished. And of course, for these machines, let's out the 0. Of course, for this machine, if you look at 5-axis settings. Yeah, tilt plane, yes, we are using tilt plane. Okay, plane spatial, and this is a code. And also the TCP, also we use TCP M128 and M129, right? So if you want to know detail about how to edit the PGF, please look at the previous video. The video number, yeah, this one, number 4, on the harsh one. I've done an explanation how to edit the PGF in detail on this video. Right, so after you're done editing the PGF, the NCFG file, next is to simulate I have the test file here. Let's open this test file. Right, so let's double click the setup and change the machines to 5x table head, this one, right? Okay, and the pulse, the post processor will be this one here. Okay, and then okay, and let's preview. Right, so 200, I think should be enough. And okay, let's save the file and let's do the simulations. Okay. Right, here the code. Okay. And let's simulate. Yeah, the motion of the z-axis limit. Okay, look here, too low, the z is too low, right? So let's make this change the setup again. So I want to move it up a bit, another maybe 300. Okay, make it higher. Should be okay. This one. And one more thing about the pulse, if you have problems simulating the pulse, make sure the pulse parameter, you need to select this one. I'm going to show you. Yeah, here. To use the plug mode, that means your dongle, Cimatron dongle, must register to this pulse. Okay. Then you can use the plug mode. That means if you use this mode, there's no limitations. Yeah. If you just want to do some simulations only, so you can always use machine simulation mode. So you can always use this mode. Yeah. If you don't, if your Cimatron plug is not registered, or you can always use this mode. Demo only, maximum number line is 88. Okay. Right, so let's go and simulate it. Okay. Right, so here's the code, and let's do some simulations. Let's zoom it up. Now I'm going to explain the a pulse parameter fitting motion to machine limits. For example, this machine is DMU60. The X, we have a big travel 715, but the X plus only 130. We can test it out, right? So we can move this side quite big movement that we can move, but on the plus side, this is the maximum that we can go. Okay, so what happens if we have a part bigger than this? How to solve this? Just for example, I have a part like this here, and this part is almost diameter 500. Yeah, diameter 500. So I'm going to use this test file here. So this is one example. Let's say I'm going to make a profile, right? Do a profile like this on the screen. Okay. So this is a 0 point. So for this side, no problem. But at the right hand side, we will have some machine limit problems. Okay. And this procedure, I'm creating this procedure by using the model UCS. That is the machine UCS that we set. The second one is the same profile, but we rotate the model UCS to create another new UCS. Rotate by 90 degree. Okay, rotate by 90 degree, creating the same profile. And last one will be the this one will be a fly axis procedure, cutting all around the part. Okay, let's do simulation. I'm going to choose only these three. Do a simulations. And let's look at the current post setting that we set. So currently we don't set this one, parameter 17 and 18. We set to no, and no, nothing. Okay, that's the default. Then let's simulate. Okay, so let's display the lines and simulate. As you can see, for the first procedure we have problem because on the right hand side it moved more than the x limit. Right, our x maximum is 130, but it moved more than that. You can look at the data over here. No. It need to move by x162, so error. Let's continue. Yes, there's another error. Yes. Okay. And yes. But for the second procedure, because we rotated the UCS by 90 degree, and Cimatron will automatically rotate the part 90 degree also according to the UCS that you select, right? So if we can rotate this one by 90 degree, then we will solve the X limit problem. Yeah. And the third one is the fly axis procedure, and also we are facing limit problems, right? We also facing limit problems. So we're always facing a limit problem. Yes, this all is overlink the X. Okay, so let's exit. So without changing the pose parameter, we can always rotate the UCS to move so that the Cimatron will rotate the table 90 degrees before cutting, so it will solve the limit. Okay, but what if you want to force it? You know. Now I'm going to select the same tree procedure and go to machine simulation. And this time I'm going to change the pose setting to Faucet. And I'm going to change fitting this one. This is the parameter that I'm going to choose. Fitting motion to machine limits. By default it is no, so I'm going to choose by the whole procedure. Most of the time you will choose this fit by the whole procedure, and click OK, and then OK. And now let's look at the simulations. You can see that by selecting the adjusting the fitting motion to machine limit parameters, the pose will automatically fit the motion to the axis limit, so that there's no over limit problem. Right, no error. Okay, I'm drilling 4 holes here. On the left hand side, these 2 holes should not have problem, but the right hand side will reach the X plus limit. As, let me show you. And X plus limit. If we use the default pose parameter, we will have this problem. Okay, because the default the pose is moving the XYZ to position the hole, and this causes the limit error. And how to solve this one? Let me do simulation again, but this time I'm going to change pose parameters, pose versus setting. And just in here, yeah. So the default value, right? This is a default value. No. Because this is drilling, we cannot set this one. This is only for non-drilling procedure. Set the whole this one only for non-drill procedure. So for drill, we need to put here. So in this case, we select minimize X, because our X plus only 130. We need to minimize this. The movement, and OK, and then let's look at the simulation. Right, now let's display the curve, and now we can see when I say minimize X, the post will automatically fit all the drilling point within the X limit. And we have a X limit error. Why? Because for this machine the X plus is only 130. So how to solve this problem? You can see here the hole is not straight, it's actually tapered 10 degree, you know. To solve this one, the first thing that we need to do is what? Because we have to use the plus angle, okay. So in this case, I will change here. My machine is DMU60 now. Okay, you must know what machine you are using. So I'm going to use by the default for this machine. The post vessel is negative angle. So therefore, this hole I will force it to positive angle and key in a B axis. Okay, this is step 1. Now step 2 is to change, let's go simulations, change the post setting. Right, these two parameters will not solve the problem, right? To solve the problem, we need to change the plus. The default for these machines that we set inside the post, if we look at the MCFG file, right, and the limit for the B is 0 to -120. That means we always work on the minus side, right? So in this case we cannot, we have to work on the plus side, and the plus side maximum angle for the machine is what? So it's 30. So we put in 30 and then OK, and then let's simulate. Right, let's see how it moves now. So you can see now the head is moving to B10 10 degree plus angle, because we set our maximum to 30 and we set this procedure, the preferred angle is B plus. That's why now it will rotate the head 10 degree and solve the limit problems. Okay, now I'm going to show you how to reset post parameter to the default value. To do the reset, you just go click on the setup and click on the post here. And this is the post parameter. Let's say I've changed this one just now. I've changed to 30, right? And here maybe I change to this one, and I change to this one, right? How to reset all the parameter back to the default? This is the how you go to reset. No, just click this one. Wait for a while, and it will bring all the settings back to the default, right? This will show you the MHD file, the post information, right? The post processor informations that the post developer write here. Sometimes you may need to read. For example, sometimes some customers, they request to modify something, so we will put all the modification here. List down the modification here. Yeah, that's it for this